Good evening, students. Continuing with the discussion on projection of lines. In a previous video, if you refer to the first video, which I uploaded, we have solved type 1 problem where normally uh, we have the true length of the line, that's 80 mm, and they have asked in order to find apparent length and apparent inclination, and they have given the true inclination and one end. Normally, we specified one end. By with that one, right, we were able to find the apparent lengths as well as the apparent inclinations. Now we have a type 2 problem where he specifies both the ends with respect to the HP and BP. That's what we can see here. And he mentions the distance between the end projector. I had given one int while solving the previous problem, and the same int we are going to use in order to find the apparent inclinations as well as length. So here he asks to find the true length and apparent inclination. Automatically we'll get all the inclinations as well as the lengths when we are going to take up the problem. So to start with the problem, as I said in the previous problem, so we need to follow a few steps. Okay, so it should get like habituated. So in the exam there will not be any confusions if you practice in that way, and it avoids many mistakes. Okay, so we'll have the same checklist here. So true length they have not given, they have asked here, so I will put a one question mark here. And apparent length, again we need to find here, we put a question mark, both the front and top here. And even the inclination they have not specified, so again I will put one more arrow mark here, sorry, a question mark. And pi, again one more question mark. And even apparent inclination they are not specified, we need to find. We'll have one more question mark. And here again beta, we need to find one more question mark. And here when it comes to the two ends, so A he has specified 20 and 30, similar to the previous problem, and B also he specifies as the B is, let me just drag this little. We'll have B is 60 millimeter above HP and 70 millimeter in front of the VP. So that's what he specifies here with respect to the VP and HP. Okay, so we need to find all these apparent lengths, apparent inclination, true length, and true inclinations and all. He specifies these two. So apart from these one, so he specifies distance between end projector. That is what is very important in this one. Distance between end projectors is equal to 70 millimeter inches. That's very important for this problem to just move on. Okay. Again, to start with the problem, we normally take up uh, the XY line from the previous one, and VPHP, and I'll just copy paste here. Sorry. So to go with that one, so we'll first notify with respect to the NDA. NDA is 20 mm above HP, right click, and 30 mm in front of VP. That's what normally we get. And when it comes to the text here, so we'll have A dash here and A here, and a smart dimension, usual one, we'll have 20 and 30. Okay, so now there are two ways by which you can locate the end B here. So end B is 60 mm above and 70 mm above, 70 mm in front. So we can just drop a two lines here, just like that, two horizontal lines, one above and one below, and go to the smart dimension. Click on the XY line and the above line and drag it to the left side. So here we need 60 mm. Enter. Okay, and same repeat the same. So repeat the same step here. We'll have a line uh, in front of the VP, horizontal line. Keep it 0.13. So go to smart dimension. Click on the same repetition here. So we'll have it is 45 mm in front of the VT. Okay. So that's exactly we can locate both the ends of the line here. When this one is done, uh, yeah, there is one change in this one. While reading the problem, it is now it's a 45 mm in front. So here we have taken it as 70 in the initial stages. So just take it as 45. Okay, that's one change. When this one is done, okay. So as we discussed in the previous problem, locating these things, what we call a locus line, is a very important in solving a lines problem. So we'll locate all the four locus lines here, and we'll just go with the locations here, locus line, and we'll just move this one a little bit up, and we'll copy paste these things to the four lines where we get all these ends of A, B, and A dash B dash. Okay, let's zoom little bit now and move this near to this one. So now, as we said, right, the very important data which they have provided in this one after these endpoints is there is a one vertical line which is stands for the distance between end projector. The distance between end projector means the distance between point A line and the point B line will be 70 millimeter. They have specified. Just drop one vertical line randomly, then go to the smart dimension. The distance between end A and this line, keep it above, and it is 70 millimeter. It gets adjusted as we did for the previous step also. Okay, now you can observe here. Okay, so we have a vertical line and we have a end B horizontal line. The same here at the down also. So we have a end B vertical line, end B horizontal line. So now you can see both these lines will intersect at some point. So that intersection point will represent now the front and the top view, that is the apparent length of the line. So now just slowly move and connect it here. That will be the front view, and from this end slowly move at this intersection, and this will be the top view. Now you go here, there is a trim option below the line command. Trim this one, okay, and trim this one. So now you just go back to the smart dimension, click on this one, just measure how much it comes, 80.62. Just drop it down, it comes 71.69. Now measure the angle between this and this is a 30, and this and this will be 12 degree. Okay, so this is what is theta and beta. Okay, so the apparent inclination. So this is our front view and this is our top view. Keep in your mind, like, see, the true length of a line will remain same above the xy line as well as below the xy line. Okay, the apparent length will change with respect to the front view and the top view. So now we can write here the apparent inclination alpha is 30 degree and beta is 12 degree. Okay, so now how to find the true length from the apparent length? Okay, it is a reverse of the previous problem. So if you go back to the previous, what we did, we add a true length, So we add a straight line, then arc in order to get the apparent length. But here we have an apparent length. The very first thing is we need to have an arc first. Take it 0.13. Okay, from end A and end of this one. Okay, first will be the arc, then a straight line down till it intersects with the locus of B. Now join back with respect to that one will be 0.35 and join to the A. Okay, so this will be our true length. The same way if you repeat to the top view here, from end A apparent length, then a simple arc till A, then a straight line from here till it intersects with the locus of B here. So there may be little confusion, so you can just enter 90°. The line will be passing through this point and then just join here, change it to 0.35 and join till this point. Okay, now first we'll check it out whether we have done it properly by checking the true length. Here it's 82.45 and here it's 82.01, so there is a little mismatch in that one. Maybe we might have connected it in a wrong way. Yes, yeah. Okay, so be careful, just delete that line. So start from here, end of this one and end of this line here. Just a little confusion. Have end E, a line, okay. So you can see 82.01. That means like even a small change in uh, taking a property of a line will lead to a error. Okay, so that means here now you can check it out here. So the true length 82.01, both above and below the x value. Now zoom the line properly. Now go back to the angle between. Let's find what is the original inclination. So 82.01 is this line. Drop it near to this one. It's 29, and from here to this line will be 11°. So almost it is very close to that one. So now let's zoom in and right here the true length is 82.01 mm and apparent lengths are, so one is 80.62, that's a front view. The top view is 71.59 mm. Down the front view is 80.62 mm. So the true inclination here is 29°. Then with respect to VP it is 11°. Okay, so like that we can find all the dimensions. The dimensions are very close because even the inclination is very nearby that one. So if you just check out, right, so in the previous one the key point to check whether we have done it properly or not is the front and top view will come on the same line. Here the key point to check whether we have done it properly or not is getting a true length same in both above and below the xy line. So this is a type 2 problem where normally it specifies with respect to both the ends and distance between the end projector. Then we will ask in order to find the apparent lengths and the apparent inclination. Okay, if you are able to understand these two problems, Then like most of the problems you can just solve by taking the initial steps. Okay. So very important thing again to remember is when they give the true length, to get the apparent length, we drop a vertical line then arc. Whenever they give a apparent length, to get the true length, we first draw the arc then a straight line. Those things you need to remember carefully. Okay, so if you have any doubts you can just comment here, so we'll look back to that one. And there is a little technical error with respect to the mouse, so not able to drop the lines properly. So that means that we are just keeping the same thing, we're not editing all those things in the video, just to know or to make sure that like, so these things may happen and leads to the mistakes also. Okay, that also you can understand. Okay, if you're in a hurry and if you're going to do the problems just like that without following the properties of a lines and all, you will not be able to get the required values or the expected values. That may lead to the uh, wrong in the problem and it leads to the deduction of the marks also. Okay, so right. Thank you.